All right, let's get in the time machine. Talk about long division. Why are we talking about long division? Because what does division do? Okay, division gives us the factors of a number. And we're spending a lot of time talking about factoring, right? So, not to spoil too much of this, but we're going to be dividing with polynomials. So, we need to discuss how to do long division first as a method for factoring polynomials. So, let's review how this process works. Okay, first of all, this top part, this is called the dividend. Okay, you've heard that term before. This bottom part, that's called the divisor, right? Sometimes when it's a fraction, it's right numerator, denominator. When we turn this into a long division problem, the dividend goes under that division symbol and the divisor goes outside, right? And then we say, okay, what do we multiply 6 by to get 1? And you can't, right? What do we multiply 6 by to get 12? And that's 2. That 2 goes above this 2, right? Lining this up is very important, and it's going to be very important for us when we start looking at this with polynomials. Then we take this number, we multiply it by that number, we write that product here, we subtract, right? We do this subtraction, we end up with 0. Then we bring this number down, okay? And we say, okay, how many times does 6 go into 5? Or what do I multiply 6 by to get 5? And you can't, right? So we put a 0 here, right? Then we do 0 times 6, which is 0. We do our subtraction. We end up with 5. When we have no more numbers to bring down, this is our remainder, right? Okay. Couple of things we can do with the remainder. When you were in 4th or 5th grade, when you were doing long division, the first time you might have said remainder of 5, okay? And then as you did more work with fractions, you may have said, well, this is 20, and the remainder gets written over the divisor, right? As a mixed number here at the end, right? This is what we're going to be focusing on, format that ends up like this. So when we end up with our remainder, that remainder comes back up and into the numerator of a fraction, okay, with this original divisor or the original denominator here, okay? So what does this mean for us when we want to do this? Again, why are we doing division, right? We divide to figure out what we multiply by. In fact, let's go back here for a second. So what does this mean? This means that 6 times 20 and 5/6 is equal to 125. Okay, so by doing division, I'm coming up with the number that I multiply this by to get this number. Okay, so one of our tasks in this chapter is factoring, right? Trying to figure out, well, how do I factor? And you might be able to just factor this problem, and you probably could very easily. Some of them are not going to be as easy when we get down the road when we're dealing with 5th degree polynomials and such, okay? Which can't be right? We don't have a process for x to the 5th, right? We have a process for factoring this, but we're going to practice long division with something easy like this for now. So when we set this up, the divisor goes on the outside still, okay? The dividend comes underneath here. Now, when we write the dividend under here, we want to make sure that we have every degree of x represented down here, okay? So whatever the highest degree is, whatever the highest exponent is, in this case it's a 2, I have to have a representation for x, and I have to have a representation for one of these floating constants. All right, you'll see some examples that we're going to go through later where this polynomial might start with cubed and go to just another x term right after it. If that's the case, we have to write a 0x squared as a placeholder, okay? Now, the process for long division with polynomials is very similar to the process that we do with just integers, okay? The difference is when we're trying to ask ourselves, well, what do I multiply this by to get this? We only look at this first part, this first term in this binomial. So in other words, what do I multiply x by to get x squared? Or how many times does x fit into x squared, right? So what do I multiply this by to get this? And that would be x. And we write that x above this x term. Lining this up is crucially important, okay? So then after we put this, okay, think back to what we did here. What did we do? we said, well, how many times does 6 go into 12? Or what do I multiply 6 by to get 12? And it was 2. Then what did we do? We took the 2 times the 6, and we wrote that number here. We're going to do the same thing with this. We're going to take the x, we're going to multiply it times the x, and we're going to multiply this times that 6 now. Okay, so we have our two x terms here, x squared and our x term. We're going to subtract. X squared minus x squared is nothing. Those should go away, right? 11x minus positive 6x. Be careful, even though these terms are separated, this is really 11x minus positive 6x, which is 5x, okay? And then the process repeats. We don't come back into here. What did we, again, I'm going to relate it back to what we already know. We said, okay, how many times does 6 go into 0? It doesn't. So we had to bring down this 5. We said, okay, how many times does 6 go into 5? And we said 0. We didn't come back up here. We started, we focused our eyes down here after that point and said, how many times does 6 go into that, right? So we're going to do the same thing here. How many times does x go into 5x? Or what do I multiply x by to get 5x? And the answer is 5. So we put a 5. Because my answer to that question is just the integer 5, I put that integer above this integer. 5 times x is 5x. 5 times 6 is 30. And I bring this 30 down so that they match up. Okay, so that I actually have something to subtract this from. 5x minus 5x is 0. 30 minus positive 30 is 0. So I have no remainder, right? And when there's no remainder, you may want to make a note of that. When there's no remainder, that means that a few things, right? That tells me that I can multiply x plus 6 times x plus 5. So here's our grand conclusion. X plus 6 times x plus 5 is equal to x squared plus 11x plus 30, right? Why do we do division? So that we can figure out what we multiply this by to get this. So we found out it's x plus 5, and there's no remainder, so it works out perfectly, okay? Now, when there is a remainder, we'll get into some examples of that, but I just wanted to emphasize that the process here is very similar to what we do with integers, okay? And our final answer can be expressed two ways. I can say, yes, this times this is equal to that polynomial, okay? Or we could express our answer as the quotient, right? Where we said, okay, therefore, x squared plus 11x plus 30 divided by x plus 6 is equal to, and then we just write our quotient, right? The answer, right? We're more interested in this, right? Because we want to be factoring. We want to write that product of factors. Okay, that's what we spent the first couple of days on here. But we can also express this as just the quotient, right? They're calling it q of x and the remainder r of x, which we don't have.